All right, Math 2, here we go. We've got 7-8 inverse trig functions. Our question today that you're going to need to answer at the end of the notes is what is the inverse of tangent -1, used for? So what is that whole thing about? So today we're going to use inverse trig functions, which would be the ones that we're going to use are the inverse of sine, the inverse of cosine, and the inverse of tangent. Now, these functions undo sine, cosine, and tangent because everything in math has kind of like an opposite, like addition and subtraction undo each other. Multiplication, division, they undo each other. Squaring and square rooting undo each other. So pretty much every function that we have in every operation that we have in math kind of has an opposite that undoes it. So we call it inverse here. So what we're going to do is in previous lessons, you have used sine, cosine, and tangent to solve for sides. What we haven't done is solved for angles. What if it's the angle that we don't know? And we already know the sides. So in this case, we're going to use our inverse trig functions to solve for angles. So here's our first problem. So our angle of reference is theta, and for some reason, mathematicians, when they're looking for an angle, a lot of times they use the Greek symbol theta, and that's what that is. That's going to be our angle of reference that we're looking at here. So remember, when we set up these problems, just like we did on the SOHCAHTOA section, we're going to write which one's the opposite leg, which one's the adjacent leg, and then which one is the hypotenuse. So the 16 would be the opposite leg, the 5 would be the adjacent leg, and then this side would be the hypotenuse. So in this case, I've got my angle of reference, my theta right there, and I've got an opposite and adjacent. So which one of our trig functions uses opposite and adjacent? Well, sine is opposite and hypotenuse, so that's not going to work. Cosine is adjacent and hypotenuse, and that's not going to work because that has hypotenuse. Tangent uses opposite and hypotenuse. So we're going to use tangent here. So I'm going to say the tangent, because remember when we set up a trig function, we always start with, or a trig equation, we always start with our trig function. Then we do the angle. I don't know what the angle is. We're just going to call it theta. Is equal to, and then the tangent function is the ratio of the opposite over the adjacent. So this is going to be 16 over 5. Okay, now I don't really need to do anything over here because that's kind of already done, but I want to find out what the angle measurement is. Problem is, right now I've got the tangent of that angle. So how do I get rid of tangent? Inverse tangent, because remember, inverse tangent is the function that undoes tangent. So I can take the inverse tangent of both sides. So I now have the function theta is equal to the inverse tangent of 16 over 5. Okay, so calculator's on. So for this one, I'll do it on this calculator first, and then I'll do it on like a phone calculator, just in case you're using that type of calculator. So first of all, just like all of our other ones, if we've got, sorry, I'm trying to find my calculator. Forgot to get it. Okay, so just like on all the other ones, we type it in exactly as we see it. Now you'll see right up above tangent is inverse tangent up here. So we're going to have to hit the second button, then tangent. So now we can see it's tangent -1, so inverse tangent of 16 divided by 5. And it comes out to 72.64. So this is about 73 degrees. All right, so that's that type of calculator. Let's look at this type of calculator now. Remember, this is the one where you kind of do everything backwards. So in this case, we would do 16 divided by 5. And then we're not going to hit inverse tangent because right now it's showing a 5. So we have to say, okay, what is that equal to? 16 divided by 5 is 3.2. And now we use the inverse. Now, you'll notice that inverse tangent isn't showing up. You have to hit the second button first. So second, and now you can see inverse tangent is showing up. So inverse tangent, and we get 72.64, which is what we had before, which is approximately 73. All right, next one. My angle of reference is theta down here. So this one would be the opposite leg. This one would be the adjacent leg. And this is my hypotenuse. So setting these up, I've got adjacent and I've got a hypotenuse. Which one is that? Let's see. So that's opposite hypotenuse. No. Ka, adjacent hypotenuse. Ah, it's cosine. So cosine, then we put our angle of reference, which is theta, equals, and then it's adjacent over hypotenuse. So 10 over 18. Okay, I want theta by itself. So we do the inverse of cosine on both sides. So theta would be equal to inverse cosine of 10 over 18. So remember, on this type of calculator, you use second, then cosine. So it says cosine -1, and then 10 divided by 18. Enter. 56.25, let's just call that approximately 56 degrees. All right, how do you do it on your other calculators? So on this calculator, we're going to do 10 divided by 18. Do not hit inverse cosine yet, because right now it would give us the inverse cosine of 18. We want it 10 divided by 18, which is equals 0.55555, repeating. And now we do the inverse cosine. So second, and then cosine -1, so inverse cosine. 56.25 is exactly what we got before. All right, last one. We got a whole bunch of stuff to solve for. So we've got over here x, y, z. We've got a whole bunch of stuff to solve for. So let's start over here with x. So that's my angle of reference. So this would be opposite. This would be adjacent. And then I don't know where we're at because somebody just brought me a chorizo breakfast burrito, and it's delicious. All right, so let's see. We were trying to decide what to use for x. Okay, so we're going to use opposite and hypotenuse. That would be sine. So I'm going to say the sine of x is equal to 15 over 17. Opposite over hypotenuse. So x would be equal to the inverse sine of 15 over 17. All right, so inverse sine of 15 over 17, so second sine 15 divided by 17, equals about 62 degrees. 61.927513. Okay, we'll just call it 62. All right, so approximately 62 degrees. All right, if I wanted to find y now, well, now this one is the adjacent, and this one is the hypotenuse. But let's stop and think about it. Do we really need to do that? Because at this point, I know that this is 62 degrees. And what did we say about these two angles before? we said that they have to add up to 90 degrees. So instead of doing that, let's just do that x plus y equals 90. And we just found out that x was 62. So if I subtract 62 from both sides, I get that y is equal to 28 degrees. All right, now here's a little bit of a problem that we have. We have rounded numbers for x and y. So if I want to use one of these numbers for z here, I've got a slight problem because, you know, a rounded number is going to get us farther off. But let's think about this. I've got two sides already, and I look for the third side. So in this problem, I don't need to use sine, cosine, and tangent to solve for z, because I can use the Pythagorean theorem instead. Okay, so when we come to these problems, don't just automatically go for sine, cosine, and tangent, because I know a lot of you would probably go, oh, I'm going to use cosine of 62 degrees equals z over 17, then I'm going to solve it. Or I'm going to use the tangent of 62 and get 15 over z. Well, the problem is 62 is a rounded number, which means we're going to get farther and farther away from the actual answer, and we want to be as exact as possible. So what we can do instead here on this problem is just use the Pythagorean theorem, and then we'll get our exact answer. So I could have just done z squared plus 15 squared equals 17 squared. Don't forget the Pythagorean theorem. It's always available for us. So we would just do z squared plus 225. 17 is 289. Yeah. And then subtract 225 from both sides. And we get z squared is equal to 64. And then we take the square root. And the square root of 64 is 8. And there's our final answer. Z must be 8. All right, that's all I got for you, Math 2. Math hard. See you later. Bye-bye.